Welcome to today's webinar, How to Cut Direct Material Spend by Reusing CAD Models. This is Joseph Lewin, and I'm going to be the one driving the presentation today. Some of you may have spoken with my colleague Andrew Hood, and he's going to be the main point of contact here at Part Solutions. If you have any questions, we'll have his email up at the end, and you can definitely reach out to him. Before we get started, there's a couple housekeeping notes. This is a 45-minute session. We will have you out of here promptly within 45 minutes. This is an educational webinar, so definitely get out a pen and paper and get ready to take some notes. And then finally, please submit the questions in the comments or the chat, and we will definitely reach back out and get answers to those questions. So with that, let's go over the agenda for today's webinar. We're going to talk about how change is essential. We're going to talk about how part reuse cuts costs. We're going to talk about the 5 pillars of the reuse method. And then we're going to go over some next steps that you can take to start implementing a reuse process in your organization. Before we dive in, I'd like to give you a quick overview of who we are. So we are Cadena's Part Solutions. We have 2 main products. So we have eCatalog Solutions, which is a digital product catalog platform. So we work with manufacturers to provide digital CAD models of the parts that they manufacture on their website. And these are then certified by that manufacturer to be accurate. And then engineers are able to go to their website and download certified models. This increases sales for the manufacturer, and it helps engineers to make sure that they're using the accurate models directly from the manufacturer and get access to those models right away. Then we have Part Solutions, which is a digital parts management system. Part Solutions is really a reuse software for engineers. So we help engineers find CAD models using 3D shape search and certified CAD content from the manufacturers that we work with. So with that, let's go ahead and dive in. So first, we're going to talk about how change is essential. No matter what's going on in the world, there's always changes that are happening. There's demands of the consumer, and there's global competition that comes in and can squeeze margins and force companies to have to innovate faster. And the people who are really driving a lot of that change are consumers. And as consumers, we want better products, and we want those products faster, and we want them as cheap as possible. That puts a lot of pressure on companies to constantly be having to innovate and create new ways of doing things, new products, while at the same time cutting costs and bringing costs down for consumers. So in order to counteract that pressure from the market, companies have to figure out new ways to cut costs while increasing their speed to market for new products. And that's where part reuse comes in and helps to cut costs for companies. So we're going to cover 2 ways that companies can cut costs by reusing parts. The first way is cutting human costs by increasing engineers' efficiency. And then the second way is by cutting direct material spend, and therefore cutting the overall cost of the parts that are purchased for new products. So in an ideal world, engineers spend 100% of their time engineering. They're in their CAD software, they're in their CAD design workflows, and they're spending all of their time creating new designs. But in reality, the engineering process looks a lot more like the bottom line in this illustration than the top line. Engineers are constantly being pulled out of their workflow to answer emails and join meetings and work on paperwork. And then the little bit of time that they actually are spending designing in CAD, they're constantly being pulled out of their workflow to search for parts. So then there's this problem. In fact, engineers spend as much as 25% of their time searching for and recreating supplier parts. So there's this gap in the engineering process between an engineer needing a part. Then they have to go and try to find that part either in their system or from online. And then if they can't find it, they end up having to design a new part and continue on. So every time a new part's needed, it takes time for engineers to either find it in their system, find it online, or recreate it. So this pit here of parts represents a file management system for CAD models. So product data management system or a product lifecycle management system, whatever way your company manages CAD, this pit of parts represents that file management system. So think of that file management system like the jar of bolts that I have in my garage. Every time I finish a project and I have leftover fasteners, they go into this jar of bolts. And I store it there so that in the future I could come back and hypothetically be able to find that part and use it again. But inevitably, when I start a new project, I look at that jar of bolts and I go, man, I don't even know if I have what I need in there. So I might as well just get some new fasteners. It's going to be less time consuming for me to just go pick some up anyway. So I go to the hardware store and I buy some fasteners. And then when that project's over, I have a few left over and they go into that jar of bolts. So in the jar of bolts example, each screw that I have in there represents a certain amount of sunk cost. It represents my time that went into getting that fastener and then the material spend that I spent to actually purchase the fastener itself. So every part that I add into that jar of bolts, I'm adding costs to that jar. And every time I take something out and use it, then I'm automatically saving or recouping some of those sunk costs. So the same thing is true for engineers trying to find parts in your file management system. Every part that's in a PDM or PLM system, one of these file management systems, it has costs that are associated with it. So in this illustration, each one of these costs represents a certain amount of engineering time that went into designing this part. So you can see there's varying levels of design time and design costs that went into each one of these parts. To illustrate this point, we're going to talk about a bracket. So John is an engineer who works for your company, and he needs a bracket for his design that he's working on. He looks inside of your file management system, but he can't quite find what he's looking for. So he goes ahead and designs this part from scratch. So this CAD model represents $175 in John's time to design this part. But little did John know that there were actually 4 other brackets that were similar and had a similar design cost that were already in his system, but he just wasn't able to find them. So now, instead of $175 in costs for one bracket, now you have 5 similar brackets that could have been used over and over again that represent $875 in design costs. If every engineer that worked for John's company would have gone back and found these parts, they would have only had just a little bit over $175 to modify those designs for their particular solution. But instead, you have this $875 in costs. Now, a lot of people will say, well, come on, engineers get paid a lot of money and they do a lot of work. And so is it really worth their time to be going back and looking for this stuff for a couple $100 here and there? Well, the truth is that the design cost is only a small fraction of the human cost that goes into every part that's in a system. So the reality is that there's been different government research that's been done that shows that the cost of every part in a PLM system can be as much as 10 times the amount for documentation and downstream processes as it was to design the part originally. So you have things like the part has to be approved by a manager, and there's analysis and testing that has to be done on the part. And then you have the purchasing department that gets involved, and they do a make versus buy analysis. And if they decide it needs to be manufactured, then you need potentially CAM and CMM software to be programmed. So all of those costs add up. So that $875 quickly turns into $8,750 when you include all of those downstream processes involved with designing those brackets and getting them ready for use in the real world. So then you have your CAD model on the left, but then you actually end up needing to purchase that part to be used in the design, and that's where direct material spend comes in. So now let's take a look at how part reuse can help cut direct material spend by going back to that example of the 5 engineers that designed these similar CAD models. So the CAD models on the left represent the different designs that were made by engineers, and then the ones on the right represent different vendors that those brackets were purchased from, since they were purchased at different times. This is a very common scenario, especially in large companies where the same or similar parts could end up being purchased from different vendors. So if we add up the costs of all of the parts that were purchased, and we're comparing the CAD model versus the purchase part, so we have the 5 different CAD model designs for a total of 1,650 brackets that were purchased. So you have $8,750 in that human costs to design the CAD models, and then you have $3,131.25 for the direct material spend. And in this example, we're really showing an inexpensive part to purchase. In some cases, these parts could be 10, 15, 20, 30 times what the actual human cost was. So just keep in mind that we're showing a very simple example, but the more expensive the part is to purchase, the more that direct material spend is going to go up. And a lot of times it could actually end up being a lot more than the human cost, even after you multiply it for all of the downstream processes. So let's take a look at a second scenario. In this scenario, John's company had a reuse initiative where they consolidated and standardized off of certain brackets. So now instead of that CAD model being created 5 separate times, it gets created once and used over and over again. And then they're able to get better pricing from a single vendor that they're able to purchase over and over again because they know they'll be purchasing that part in bulk. So now you have one CAD model for 1,650 purchased brackets. So you have $1,750 in the human costs because you had the one CAD design with its downstream processes. And then we purchased 1,650 brackets at 85 cents a piece for $1,402.50. So now if we compare those side by side, without reuse, 1,650 brackets were purchased for a total cost of $11,881.25, whereas in the scenario with reuse, you have 1,650 brackets that are purchased for a total cost of $3,152.50. So that is a 73.5% difference in costs between those two scenarios. Airbus is an example of a customer of ours that implemented a reuse strategy using brackets. When they measured their brackets alone, they were able to cut the part count, the number of different brackets that they used, by 850 brackets, and it saved them 1.26 million euros a year just by focusing on reusing brackets, similar to the example that we just showed. So how can you get from scenario 1 to scenario 2 and start realizing some of those savings? Well, you have to figure out a way to bridge this part reuse gap. You have to figure out a way for engineers to spend more of their time engineering in their CAD workflows and less time searching for parts and recreating parts that already exist. And the approach we're going to talk about today is the reuse method. Now we're going to cover the 5 pillars of the reuse method. And those are measuring and data collection, think in standard parts, implementing a standard parts process, creating a culture of reuse, and managing standard parts effectively. So measuring and data collection. So a huge challenge that a lot of companies face that we run into is duplicate parts and having duplicate parts in their PLM system, and they can't figure out a way to manage those parts. And you have to start to determine how much those parts are costing you to be able to figure out whether a reuse initiative makes sense for your company. And having a good before and after snapshot helps you for analysis, and it also helps you to present your findings to leadership and continue to drive the initiative forward. If you're able to use data to show how much your company is losing by not creating a reuse strategy, it's a lot more compelling than just saying, somebody told me about this and I think we should do it. So getting that data and measuring what's going on is really important. So what do you need to measure? So the first thing you really want to measure is how long engineers spend searching for or recreating supplier parts. Second thing is, what is your engineering cost per part? How much does it cost per part for engineers to design a part on average? What is the average cost per part through the product lifecycle? Now, this is not an easy thing to measure, and you're getting multiple departments involved to figure out this number, but this is where you're really going to see the costs compound, and therefore the savings compound when you figure out your cost per part through the product lifecycle. This is a really important number to ultimately to figure out. Then you want to determine the number of duplicates and similar parts inside your PLM, PDM, and ERP systems. So this is going to help you to understand how many parts are actually being brought into the system over and over again that could have been reused. All right, so that brings us to the second pillar of the reuse method, which is think in standard parts. So to think in standard parts, first we need to cover what we mean by standard parts. Typically, there's 3 types of standard parts in a company's database. You have your commercial standard parts, or COTS, your parts that you purchase from suppliers that you could use over and over again. You have your industry standard parts, so that's going to be things like mil-spec, the NAS parts library, SAE standards, also ASME, ISO. There's all of these different standards that are required in certain industries. And then you have your company standard parts. And those are going to be internal parts that you standardize off of and use over and over again. To help you to understand how to think in standard parts, we're going to talk about Legos. So Legos are really the perfect example of thinking in standard parts. You have a certain number of standard Lego blocks, and those are used to create all kinds of different designs. And so Lego has, I think it's about 1,400 standard parts, and then they have 7,800 or so parts altogether. So they have a good portion of the parts are standard and used in the majority of designs, and then there's only certain parts that are unique. And by doing this, Lego's allowed infinite possibilities for design, and they're able to cut their costs for designing parts because they're only having to design a certain amount of molds for their Legos. And, there's been all kinds of crazy stuff built out of Legos, cars, houses. There's even a fully working car that was built out of Legos. So you could really build all kinds of things from Legos. Now, I understand that engineers can't actually use Legos for their design. And I'm glad when I sit down in an airplane that the landing gear on the airplane is not made out of Legos. I understand it's not a perfect illustration, but the idea still stands that there's certain parts that can be standardized and used over and over and over again, and then only customizing where you absolutely have to. And so what are some of those common standard parts that engineers are able to use? Well, they're things like fasteners, brackets, clamps, cylinders, extrusions, motors. There's these different parts that are relatively standard that can be used over and over again. So here's an example of a body in white facility. And in this case, 90% of these parts are off the shelf. So if you can imagine the company that designed this facility, when they go to design another facility, there's so many parts in these designs that would be able to be reused in future designs. But you have to have a way to be able to actually do that. So the main idea of thinking in standard parts is to choose certain parts that you standardize as a company ahead of time, and then decide up front certain parts that you're going to use in the design, and then design around those parts instead. So if you're able to choose 10, 15, 20, 30, 40% of parts at the beginning of a project that you're going to use, and then custom design around those parts, you're able to automatically build reuse in to your design rather than designing everything and then trying to fit those parts in after the fact. Just build some of that reuse in when you choose the certain parts to use up front. So when it comes to thinking in standard parts, especially when it comes to something like brackets, the point is, you might not be able to have the perfect bracket that will work in every situation, but you can take a bracket and add extra mounting holes to it, or add different configurations to it that aren't useful in every single design, but make it useful in a much broader context. So the more parts that you standardize and specifically create for standardization, the more that you're able to use those parts effectively across different designs. So that brings us into implementing a standard parts process. So how do you actually start to implement a standard parts process? So first you have to assign a project champion. This has to be somebody who's bought into the vision behind reusing parts. And it has to be somebody that ultimately can work with different departments, because for a reuse initiative to ultimately be effective, you're going to be in engineering and procurement for sure, but there's also other departments that could end up getting involved in the process as well. So this needs to be somebody who can really navigate different departments and be able to drive change. And then you have to map out a reuse strategy. So there's a lot of different approaches to reuse, and you need to decide and design that upfront. Then you need to establish a list of standard parts. So go back to that list of duplicates that you got when you were in the measuring step and start to look for patterns of which parts are constantly being brought in as duplicates or similar parts. And that will give you a good idea of where you're going to really be able to get value standardizing. And then you need to set protocols and governance. So there has to be some way to ensure that engineers are actually reusing parts, even if it takes them a little bit longer, rather than getting done a little bit faster but bringing in a lot more duplicates. And then you need to measure your results. Again, it's a lot easier to drive change and really make something happen if you're measuring. So you want to be measuring before, during, and after any kind of initiative. And then finally, last but not least, you want to start small and progressively grow. If you try to implement a company-wide, enterprise-wide reuse strategy that spans multiple departments and get everything together before you do it, that is a recipe for disaster. The companies that we've seen the most success with are ones who start with a small pilot program, and then they figure out what works, they design their workflows with a small group of engineers, and then they expand from there into a larger group of engineers and then move over into procurement after everything's working properly. Or sometimes it's driven from the other side in procurement and starting small in that department and building up and then bleeding over into engineering. So then that brings us to the fourth pillar of the reuse method, which is creating a culture of reuse. So the first part of that is you have to cast vision to get buy-in. Now this makes sense, and people understand this intuitively from getting buy-in from executive leadership or key stakeholders that are the decision makers of whether or not you're going to move forward on a project like this. But a group of stakeholders that often gets overlooked are the people on the ground, the engineers who are actually designing in CAD. And if you don't get them to buy in, if they don't understand the vision, then you're never going to really be successful with a reuse initiative. And so you really want to cast vision to them as well. And how do you do that? Well, show the numbers. Show them how much it's actually costing your company every time a part is designed and put into the system. Because if they think, well, it takes me 20 minutes to design this part and I add it in and I'm good to go, why would I not do that? Well, if it ends up costing your company $3,000 for that one part that's entered into the system, then if they see that, it helps them to get an idea of why this is important. So you need to create accountability. There has to be accountability for engineers so that they're incentivized to reuse parts even if it takes them a little more time rather than cutting corners and finishing their design a little sooner. And then reward part reuse, for the engineers and the groups of engineers that are really excelling at this and you're seeing your part reuse go up, then definitely reward them and give them an incentive to keep going. That brings us to the fifth and final pillar of the reuse method, which is managing standard parts effectively. And this is really where the rubber meets the road, because if it takes an engineer 5 hours to find a part, then the value goes down for reuse. And, honestly, if an engineer can't find a part within 5 to 10 minutes, they're probably not going to really spend the time to do it anyway. So there has to be a way for engineers to be able to find parts a lot faster in your system for reuse, or the whole thing falls apart. And that's what we're going to address in this section. There are several ways that companies typically approach reusing parts, and we're going to cover those in the order that they are typically pursued. And that's PLM, classification, 3D shape search, and parts management software. So PLM, or Product Lifecycle Management Systems, create workflows, timelines, and processes. PLM software ensures that projects stay on deadline by connecting people, processes, and data throughout the life cycle of a product. PLM is extremely important and valuable, but it isn't really designed for reuse. And a lot of companies are told, well, PLM is going to solve all of your reuse problems. Once you implement PLM, then your engineers are going to be able to quickly find things. But PLM is kind of like a library that houses all of this data so that people can easily access it throughout the life cycle of a product. And it increases cooperation between departments. But the challenge is when it comes to managing 3D files, 3D CAD files, it actually looks a little bit more like this. So an engineer has to go try to dig through a stack of papers, essentially, to try to find what they're looking for. And more data is there, and it's more accessible to different departments, but it's hard to actually find what they're looking for. And so after implementing PLM, a lot of times engineers are still not able to find parts, and typically companies turn to something like classification after that. So what is classification? Well, classification in its basic form is think of it like file hierarchies. So you have these different parts that you organize into categories based on certain characteristics of those parts. So maybe you have fasteners as one category, and bearings as another category, and brackets as another category. And then under fasteners, maybe you have socket head cap screws and hex bolts, and you have different levels under each one of those files. So then the idea is you click on the folder that you need, and then you can kind of drill down until you find what you're looking for. So it's kind of like a file system. So you can think of it as a way to organize a lot of that information that is in PLM. Now, classification is important for different reasons. It is really valuable. It's helpful, on the procurement side as well. But the big challenge with classification is that you're trying to find 3D parts based off of text information that's in the model. And a lot of times, especially on legacy data, that text isn't even there. The metadata isn't even there on a lot of models. So then companies kind of have a choice. They have these two primary ways of going about solving that. You have manual classification, and then you have a system to automate some of that classification. The challenge with the manual side is that it takes so much time. Sometimes it's years worth of work to go back and classify all of this old data manually. And in some cases, it's tens of thousands or hundreds of thousands of dollars to go back and do that. And then when you automate this process, the challenge with that is that it's only as good as the metadata that's already in the model. And so if the model doesn't have good, clean data, there's no way that it can automatically modify it. So then you have to go back and search through those parts manually and put metadata into those models. So it's definitely faster and better to automate that process. But the truth is, it's still extremely time consuming and costs a lot of money to do that project. And then meanwhile, there's still new parts that are coming in that have to be classified as well. So that project really never ends. So after classifying, a lot of times engineers are still not able to find parts because they're looking for 3D parts using text. And so typically after classification doesn't still solve that problem completely, companies end up turning to 3D shape search tools. And 3D shape search is a much better method for finding 3D models. The reason is that 3D shape search is searching based on the parametric information or the geometry of the part. So since it's a 3D part, it makes sense to search for it in 3D. Good 3D shape search tools are going to actually map that part, and they're going to measure the different attributes on that part, and they're going to turn what used to be 3D parametric data into searchable text so that you're able to either search based off of a model that you already have and find something similar, or you can search for a part based off of descriptions and geometric characteristics that don't exist in the metadata of the model. So companies really do end up having a lot more success with the 3D shape search than with classification or PLM as far as finding parts faster. This is an example of our 3D shape search tool in Part Solutions. You can see for that bracket example, you're able to search and find similar brackets. But then there's still a really big challenge, and that's how do you ensure that your engineers are able to quickly and easily find parts that are preferred for reuse? So you could use this 3D shape search and search your entire database and reuse parts, and that is great and that's valuable. But what if there's that one bracket that you want engineers to use if at all possible? So then that's really where a parts management system comes in. Part Solutions is a parts management software. I'm going to speak about parts management software in terms of Part Solutions. So Part Solutions integrates with all major CAD, PDM, PLM, and ERP systems. And then you're able to find parts across those systems. So you can have a multi-CAD, multi-PLM, multi-ERP environment, and engineers are able to find parts across any of those databases that you want them to be able to search using 3D shape search and attribute search functions. Then you're able to set preferred parts in Part Solutions, so that when an engineer goes to search for a part, they're able to automatically see in their search results whether that part is preferred or not. And then using Part Solutions, companies are able to get access to over 800 certified manufacturer catalogs that we've created from eCatalog Solutions, and their engineers are able to access those directly in their CAD software. So Part Solutions helps to eliminate the introduction of duplicates, helps you to find and consolidate existing duplicates, and it helps you find similar parts to create standards lists. So this is an example of brackets in Part Solutions. And so the green in this case is set as preferred, and then the orange is still acceptable, and blue means it's acceptable only in certain locations based off of a user's role, and then the red ones are not preferred for reuse. This example is search for a screw, and you're able to automatically see in the search results which ones of these screws are preferred for reuse. So now we're going to talk about our recommended process for pursuing reuse. So instead of starting out with PLM or starting out with classification, now for companies that have already done those things, there's a lot of value there. But when it comes to reuse, instead of starting with classification or PLM, we would really recommend starting with a 3D shape search tool to find parts. Especially when it comes to searching legacy parts and classifying all of that old data, you really don't have to classify everything in your legacy data. You just need a way to be able to search and find the important stuff that you want to reuse again. And then the value of starting with 3D shape search is that as soon as you implement the software, which doesn't take that long to get it set up, then you're able to immediately start seeing results from that. Whereas with classification, it really takes months or even years before you can see the benefit of that. So there's a lot of opportunity and costs involved with that. When you start with 3D shape search, then you might not even end up needing to spend the money to classify that old legacy data. And then you use that 3D shape search tool to find duplicate parts so that you can set preferred parts for reuse into the future. Then you want to classify everything moving forward. Now, I know I've said some negative things about classification as far as using that for reuse, especially reuse of legacy data, just because it's so expensive. But classification is a very valuable tool, and you want engineers to be classifying and putting good attribute data into the models as they create them moving forward. If you have classification, good attribute data, and 3D shape search, engineers are going to be able to find parts so fast, it will blow your mind. And then you want to set up PLM workflows to ensure that you have quality data coming in. So you want to really force engineers to have to put in certain attribute information or classification information based on PLM workflows. And then once all of those things are set up and implemented, engineers are going to be able to quickly and easily find preferred parts for reuse and help you to realize some of those savings. So what are the next steps? Well, first, after you're done with this webinar, we're going to actually send you a free ebook on reuse. So you can check that out, and we'll send you some other free resources as well. And then any questions that you've asked, we'll go ahead and answer those questions and get back to you. We're available if you have any more questions, so definitely don't hesitate to reach out. Now, my colleague Andrew Hood, he's going to be your main contact at Part Solutions, so feel free to reach out and email him. And really the next step is to get on a discovery call with Andrew and talk through the different workflows that you have right now and talk through your particular situation. And he can help to walk you through some of that and guide you through some of the steps to start to set up what we've been talking about. And if a parts management system makes sense for your company, then we would go ahead and set up a small pilot and be able to show the results that you'll get from a reuse strategy. So thank you so much for joining this webinar, and we look forward to continuing the conversation with you.